Good afternoon, ladies and gentlemen. I've been told to stick to time for sure. I'll try to maintain that. But I would like to thank NASCOM for giving me an opportunity to talk about the next revolution in happening, which is intelligent edge. So let me begin with two of my experiences where this has really taken me into the technology world. I come from semiconductor background, so we've been hearing about supply chain issues and other things. I will definitely talk about it. So I believe most of us in this room, I just Googled what is our age group look like. It's called Zennials. So we do believe that most of us will relate to what I say. This was during my childhood days where I used to watch this series back in 20th century, late 20th century, I would say, 90s and 95s, called Knight Rider. I'm sure everybody here would relate to that. I was really fascinated with the technology then, or I would say the science fiction, right? Where the human machine was talking to or the humans and machines were talking together, right? And in fact, I went ahead and named my bicycle also so that one day it would converse with me, right? So that's the technology what we have been learning about science fiction. The other technology, I would say, is just recent past, I would say a decade back, where I was part of this bionic eye project. I think it's still science fiction for all of us here. So it's a chip where we developed and implanted in a human being in the eye, right, for a blind person, especially for retinal pigmentosa ailment. So that was an amazing journey. Of course, not in India, it was in Melbourne, Australia, where the technology where they were building was to just send the data and the power wirelessly, right? And the problem where we saw is that the patient would see the image in a hazy way just after the event, right? So that's something which was 10 years back, but with the technology which is going to improve in next decade, I think that's going to change the revolution. So the big fours, coming back to reality, the big fours are investing around $300 billion projected money into the data centers. But why so much? This is because the humongous data which is being pumped into the cloud. That's zettabyte of data. I don't even want to go and count the number of zeros out there, right? So it's pretty humongous. And if we are talking about zettabytes of data going into the cloud, that means you need a nuclear power reactor one day to power up and cool up. And on top of it, the real estate, right? This is something which is really sustainable. On top of it, there is another thing which, since I come from semiconductor, NVIDIA's chip costs whopping $30,000 for one chip, right? That's huge. That's huge, right? We in India, we talk about, a dollar chip, $2 chip, right? So that's pretty huge. And is it really sustainable? Probably not. I think we have to move on to arresting this. It's not that arresting the data itself, but making the data meaningful. That's where the intelligence edge come into picture. In fact, I want to go one level ahead, get the intelligence to the node. We talked about IoT sensors just a half an hour ago. So we need to bring those edge or the node intelligent enough. So we don't require a microprocessor out there to run this because it's going to guzzle the power, right? So you require a microcontroller out there wherein it is intelligent and powerful enough, right? So that's something which we need to look into it. And of course, the inferencing part in pure storage, the talk was happening about the inferencing in seconds and milliseconds. This is exactly what we need on the edge, right? So make the data meaningful with inferencing, right? So that's something which is required. And of course, the wireless network which has to be brought in. We are talking about wireless, Bluetooth, or the Wi-Fi, right? That has to be powered up in such a way that it can aggregate the data locally rather than having it sent into the cloud. Take the decision, send the meaningful data back. Of course, the cost efficiency is something which is need of the hour. So what are the applications where things are moving like, right? So I just spoke about bionic eye, where the event would have elapsed and then the image would have been seen by the patient. So the new technology in next decade where the bionic eye group is working is definitely on making the edge intelligent enough, right? So where the stimulation is only of required image only has to be sent inside the eye. So that's one positive. One other aspect where really things are moving towards is very closer to my heart. On one of my colleagues' daughter is suffering from diabetes type 1, right? So that's where you require to monitor the glucose all the way and then pump in the insulin. The edge AI, the chip, what the world is looking at is definitely to bring in the automatic insulin dropping into the body based on the glucose level. In fact, one level above that is AI powered pancreas, right? So that's the sector which future is looking from the healthcare perspective. Definitely automotive, we just saw cyber cabs from Tesla, where you just have to book the cab onto your phone and then the car takes you. It's as good as sitting in your launch, right? But I want to take one step ahead. You don't even have to open up the mobile app. You just have to think. How? Brain neural interface. The neurons in the mind which get stimulated by the accelerator is something which is the next frontier, right? And of course, after today's talk, I would say that early in the morning, I heard about defense. Defense should also come here from India perspective. That's positive, right? We saw that supply chain issues which is happening, and of course the IoT sensors, the chips have to be brought in here. So this is something which the world is looking at, and of course the industrial sector is something which is no-brainer. Industry, we have to step onto industrial 4.0 revolution. So with that, SenseSemi's future chip in making. We are still developing a chip. Probably mid of next year, we would have our first test chip. As silicon is expensive. Silicon, we cannot go back to software and say that we can fine tune the chip. We have to retape out the chip. So that's slightly difficult, but we are in this game for sure to make sure that SenseSemi is on a mission to democratize the edge AI into devices what human beings are going to use. With that, I would like to end my talk. 12 seconds, but there is a small video of 60 seconds which I would like to play. It's something where we are working with one of the customers on the healthcare, where the problem is, especially with respect to syncing the data, then retrieving it. It takes around 4 minutes, right? And we are talking about milliseconds of data here, right? This is where we have brought up the FPGA, we call it, as a prototyping level. And we have gotten that into making sure that we can get that in milliseconds. So probably the video would, I ran up time. Time's up is something which is showing me, so I can't really show the video, but I'm here to talk about more when we meet. That's all I had. Thanks.